Hey everyone, Math 103. We're continuing on today with section 6.1. We're going to be multiplying and dividing rational expressions. So a little review. When multiplying fractions, we're going to multiply numerator by numerator and denominator by denominator. So just multiply straight across. So for example, if we want to multiply 2/5 by 5/7, we're going to multiply 2 times 5 on top and 5 times 7 on the bottom and get 10 over 35. Your turn, number 1. 6/11 times 2/5. Multiplying straight across, you got 6 times 2 is 12 for the numerator, and 11 times 5 is 55 for the denominator. Now we're going to multiply some expressions that have variables in them. Now we can either simplify before or after multiplying, but in any case, we need to have a simplified answer. So in this case, what we can do is simplify across fractions, and that's totally fine as long as we're doing multiplication. Cannot be done with addition or subtraction. So in this case, we've got an x that cancels, an x on top and an x on the bottom. And I'm just going to go ahead and rewrite this without the x's now. So we got 9 over 5 times 2 over 7. And now that we've eliminated the variables, now we have a problem just like the first one. So let's multiply across. You get 18 on top and 35 on the bottom, 18/35. Your turn, number 2. Now in this one, we've got 2 x's on top and 1 on the bottom, so I'm going to cancel those out. And if I rewrite this one, we get 8 over 1. Keep in mind when you cancel, you leave behind 1, not 0. And over here, we got 2x on top and 13 on the bottom. Now we can just multiply straight across. 8 times 2 is 16, so we get 16x on the top, and 1 times 13 is 13 on the bottom. 16x over 13. Next example. All right, we've got some canceling to do now. I've got 2 x's on the bottom here, so I'm going to cancel out the x squared, and that gives us 2 x's gone on the top. And then we've also got 4 over 8. 4 over 8 as a fraction reduces to 1 over 2. All right, so there's our canceling. What do we have left? We got 3 on top, 3 times 1, so that's 3. And on the bottom, we have 2 times x. So our final answer is 3 over 2x. Your turn, number 3. All right, we have 2 x's on the bottom, 3 on the top, so we're going to get rid of 2 of those, leaving just this x on top. And sometimes when crossing out like this, it can be difficult to tell what you have left. So sometimes I just like to circle that which remains. All right, now 9/15, the fraction reduces to, if we divide both the top and bottom by 3, that's going to reduce to 3/5. So on top we got 3 times x, and on the bottom just 5. So 3x over 5. Your turn, number 4. So the first one, we've got 25 over 5. 25 divided by 5 is 5, so that gives us 5 over 1 here. We have 3 x's here and 1 here, so we can cancel one of those x's, so that exponent is going to turn into a 2. Then we have 1 y here and 2 y's down here, so that exponent is going to go away. We're going to keep the y. Now we have, on top, just 5 and x squared. So 5x squared on top, and on the bottom, we've got 2y. So final answer, 5x squared divided by 2y. And the next one, this one can get a little confusing. So what I'm going to do is I'm actually going to rewrite this. Now, when we multiply fractions, you can multiply top by top and put them all together on the top and the same thing on the bottom. Well, I'm going to do that, and then I'm just going to rearrange things so that things that are going to cancel are going to be right on top of each other. And that's a nice way to organize things so you don't get confused. So if we put 28 over 7, that's going to simplify nicely, and then we can do 25 over 20. Now we can do the variables. We got 3 a's on top and another 4 here, so there's a 7 a's total on top, so that's a to the 7th. And on the bottom we have a to the 5th. So I'm going to write a to the 7th over a to the 5th there. And on top we have 4 b's, so b to the 4th power, and right below that, b squared. So I've included everything, I haven't forgotten anything, and all I've done is rearrange things so that the things that cancel are going to be right on top of each other. And now when we go to cancel, things are going to be a lot easier. So 28 over 7, 28 divided by 7 is 4, so we get 4 over 1 here. 25 over 20, that fraction reduces to 5/4. A to the 7th over a to the 5th. All right, these are going to go away, 5 are going to go away, and we're going to have 2 a's remaining on top. And then for the b's, same thing, 2 remaining on top. So after all these cancellations, what do we have left? We got 4 times, oh wait, we have one more cancellation. After simplifying here, we got a 4 on top and the 4 on the bottom. So we can get rid of that as well. So that goes away here and here. All right, now we've got 5 times a squared times b squared on top. And on the bottom, everything canceled, so that's actually the answer, 5a squared b squared. All right, now we're going to start multiplying rational expressions comprised of polynomials. So the procedure here, we're going to factor all numerators and denominators. Always going to our first step is try to factor as much as possible. And that allows us to go on to step 2 and cancel the matching factors. So factor and cancel. 3, multiply anything that remains, and then make sure that this product is in lowest terms. Because as we saw in the last example, sometimes after you get done simplifying, you end up getting a match like this, like those 2 4s, and we can cancel them as well. So with this one, we can start right off. It's pre-factored, so we can just start by canceling the matches here. So we've got matching binomials, those can cancel. Cross fractions is fine. And that's everything that has a common factor. So now we'll just multiply straight across. 3 times y gives us 3y on top, and then 2 times x on the bottom. 3y over 2x. Your turn. Number 3. No. Pardon me, your turn number 5. So we got a nice cancellation here, x plus y. That binomial is gone. And now we've got a fraction we can reduce. We have 10 on top, 5 on the bottom. So 10 divided by 5 is 2, so we get 2 on the top, 1 on the bottom. And now we can multiply straight across, 2 times x, and y squared on the bottom. 2x over y squared. So that one came pre-factored. Next one is not pre-factored. So first step is going to be to factor. So factoring this, looks like we have a common factor of 5 between 5 and 30. So I'll factor out of 5 and get x minus 6. Now over here we can factor out of 3 and get x minus 6. 48x to the third. All right, canceling now. X minus 6's, those cancel. Now we got some cancellations here. 12 over 48, that reduces to 1/4. Then we have x over x to the third power. So that's going to turn this exponent into a 2, and that x goes away. Looks like that's all the common factors now. So on top, we've canceled everything except for the 3. And on the bottom, we have 5 times 4 times x squared. So 20x squared. Your turn, number 6. So we'll start by factoring. I'm going to start here. Looks like we can factor out 3x squared here and get x squared minus 6. Now I got difference of squares here, so this factors into x plus 5 times x minus 5. X minus 5 is now factorable, so we'll leave that. And then down here, we can factor out a 6, just a GCF here. And now we've got matching binomials. So look for that. Once you start factoring, you should find some matches along the way. That's generally how these problems are designed. All right, there's a binomial that matches. We'll cancel that. We got x minus 5, x minus 5. All right, let's see what we can do with these numbers now. We got 3 here and 6 on the bottom, so that's going to reduce to 1/2. Looks like that's it. Everything is canceled on top except for x squared. And on the bottom, we have 2 times x plus 5. Next example. Here we can factor out a 2. 2 times x minus 5. Here we can factor out 3x. 3x times 2x minus 1. And here we can factor out an 8x times 2x minus 1. And finally, we're going to factor an 8 out of here and get x minus 5. All right, time to start canceling. All sorts of cancellations here. X minus 5, those are going to go. 2x minus 1, those are going to go. We have x's here, those match, those go. We got an 8 and an 8, those go. Looks like we have canceled everything except a 2 on top and a 3 on the bottom. So that whole expression just equals 2/3. Your turn, number 7. First fraction up here, we can factor out a 2x squared. That gives us x minus 6. And down here we can factor out a 5. 5 times 2x minus 5. And up here we can factor out a 3. And here we can factor out 5x. By canceling x minus 6's, those are going to go. 2x minus 5, those go. We've got 1x on the bottom, 2 on the top, so I'm going to get rid of that one, get rid of that, keep that other x there. And that's all the cancellations. Now we've got 2 times 3 is 6, so we have 6x on the top. And 5 times 5 is 25 on the bottom. 6x over 25. Now we're going to start factoring some trinomials. All right, first trinomial, x squared minus 4x plus 3, we can factor that into x minus 3, x minus 1. And on the bottom, x minus 3, x minus 4. All right, this one, x plus 6, x minus 4. And this one's a little trickier, so I'm going to rewrite this one. This is negative x, so I'm going to write in descending order, negative x squared minus 5x plus 6. Factor out a negative 1 to get x squared plus 5x minus 6. And this will turn into x plus 6, x minus 1. All right, let's find our matches now. X plus 6's, those go away. X minus 1's, x minus 4, those go away. X minus 3's go away. That's everything except for a negative sign. So this whole thing equals -1. Your turn, number 8. So factoring this first one, that factors into x plus 3, x minus 2. Now let's see, this one I'm going to rewrite. I'm going to rewrite it down here. Negative x squared plus x plus 12. So if I go to -1, we get x squared minus x minus 12. And that is going to be x minus 4, x plus 3. Up here, we're going to have x plus 5 times x minus 4. And down here, the perfect square trinomial, x minus 2 squared, or x minus 2 times x minus 2. I usually like to write it as two separate binomials because then it's easier to cancel. So just like that. X minus 2's cancel, x minus 4's cancel. Let's see here, x plus 3's cancel. So what we're left with, we got a negative sign here, and we got x plus 5 on top, and x minus 2 on the bottom. All right, now we're going to divide rational expressions. So a little refresher about dividing fractions. We're going to take a over b, divide by c over d. We need to convert this to multiplication. So we're going to leave the first fraction alone, and then flip the second fraction over, and convert to multiplication. So we get a over b times d over c. Then just multiply straight across, so we get ad over bc. For example, we could multiply 3/7, or divide 3/7 divided by 11/7. All right, convert to multiplication. So flip that second fraction over. Now we've got a cancellation here. 7's are gone. And finally multiply straight across. 3 times 1 is 1, or 3. 1 times 11 is 11. 3/11 for that one. Your turn, number 9. Two ninths divided by 15 ninths. So convert this one to multiplication. We got 2 ninths times 9 15ths. 9's cancel. And that gives us 2 15ths. Next up, we're going to throw some variables in there. When we convert to multiplication, flip this second fraction over. And now it's just like the other ones. So we are going to start canceling. All right, 1x on the bottom, 2 on the top, so we'll get rid of that, keep that x. That one goes, that turns into a 2, get rid of one of the y's there. And what do we have here? 8 to the third over a squared. 2 a's are going to go away, so that goes away, we're going to keep that a. We got 3 b's on the bottom, those are going to go away, and that turns into a 2. Now we can do the numbers. 4 over 6 reduces to 2/3. 5 over 15 reduces to 1/3. So what do we have left now? We've got 2 times x times a times b squared. And on the bottom, everything cancels except for 3 times 3, so we got 9. So we got 2x ab squared over 9. Your turn, number 10. And, oh, I did forget something here. Yeah, this is the problem when crossing out like this. Sometimes it's hard to tell what's left. Forgot the y squared. So first up, convert to multiplication, flip that second fraction over. Now start canceling. All right, x squared, this is going to go away. That exponent goes away, we got 1x left on top. The y's, 1 on top, 2 on the bottom, so that's going to go away. Leave that. Okay, a to the third over a to the fourth, 3 a's go away, leaving just 1 a on the bottom. B to the third over b squared, 2 b's go away, that exponent goes away, leaving 1 b on top. All right, now 7 over 21, that reduces to 1/3, and 6 over 9, that reduces to 2/3. So let's see what we have left. All right, we got 2, got an x, and a b. On the bottom, we got 3, a, Another 3, so that's 9 AY. 2xb over 9ay. Now that time, whenever something was left over, I circled it. And so that way I didn't forget anything here the way I did over there. So circling what remains is pretty useful. Next example. 3x minus 9, 4x squared minus 6x divided by 5x squared minus 15x over 12x to the third minus 18x squared. Convert to multiplication. Flip that second fraction. Now start factoring. All right, first one, 3x minus 9, that factors into 3 times x minus 3. Here we can factor out 2x and get 2x minus 3. And over here we can factor out 6x squared and get 2x minus 3. And here we can factor out 5x and get x minus 3. Now we got some things that are matching, so we can cancel those, cancel those. We've got 2 x's on top and a total of 2 x's on the bottom, so those all cancel. Now we've got 6 over 2, so that reduces to 3 over 1. So what do we have left here? We've got 3 times 3 is 9 on top, 1 times 5, 5 on the bottom. 9/5. Return number 11. Convert to multiplication. Flip the second fraction over. Now let's start canceling. Got 3 y's on top, 3 on the bottom. Those are gone. 4 b's on top, 4 on the bottom. Those are gone. We got 3 a's on the bottom, 4 on top, so we're going to get rid of 3 of them. Keep that 1a. And the x's, same deal, except we're going to have 1 x remaining on the bottom. All right, now the numbers. 7 over 28 is 1 over 4. 10 over 25 reduces to 2/5. All right, what do we have left here? 2 times 1. So 2 on top and an a is left. So 2a on top. And on the bottom we have 4 times 5, that's 20. And variables, just the x. Right now, didn't quite simplify fully. We've got 2 over 20. That reduces to 1 over 10. So our final answer then would be a over 10x. And that brings us to your turn, number 12. All right, so I'm right to the first step. Already converted to multiplication. So we can start canceling. 10 over 15, that reduces to 3 over 2. Got 2 A's on the top, 1 on the bottom. We're going to get rid of an A. And then we've got that A remaining. 2 B's go away here, and this turns into B squared. Now we're going to have to do some factoring here. All right, so next up I'm going to factor here, so I can factor out 3x from this thing and get 2x minus y. And I'm just going to write what remains here, 2b squared. And up here, what remains here is 3a. So we get 3a over, and now I'm going to factor this thing. Here it looks like we can factor on 8x y squared. So that gives us 2x minus y. All right, now we got a binomial here that we can cancel. 2x minus y is canceled. And we got 3x over 8xy squared. So the x's will cancel. And that's it there. So now we'll multiply straight across. 3 times 3 is 9. So we got 9a over 2 times 8. That's 16. B squared, y squared. So there's your first step, convert to multiplication. So now we're going to factor and cancel. All right, two numbers multiply to get negative 15, add to get 2. It's x minus 5, x plus 3. All right, 45 and negative 4, that's going to be x minus 9, x plus 5. Over here, 2 numbers that multiply to get negative 36, add to get negative 5. It's x minus 9, x plus 4. And finally here, we've got x plus 4 and x minus 3. All right, let's see if we can find some matches here. Let's see here. Oh, got a mistake here. That is x plus 5 minus 3. Okay. Let's see what we got here. X minus 9s, those cancel. X minus 3s, those cancel. X plus 4s cancel. X plus 5s cancel. Looks like everything canceled. So that one is 1. So lots of factoring practice in these. So if you're having trouble with any of the factoring, go back to chapter 5 and refresh those techniques. We're going to be using them throughout the whole chapter. Have a good day, everyone.